Hi class, this is the Chapter 7 study guide. Number 1. The ratio of the measures of the angles in a triangle is 3 to 4 to 5. Find the measures of the largest angle. So when we see this extended ratio like this and we're trying to find the measure of each angle, multiply everything by x. So this ratio becomes 3x to 4x to 5x. Now each of these numbers represents an angle, so 3x plus 4x plus 5x is going to be equal to, well, these are the angles of a triangle, so they're going to equal 180. Now we just add and solve for x. 7 plus 5 is 12. 12x equals 180. Divide by 12, and x equals 15. Now that gives me x, but I'm asked to find the measure of the largest angle. And the largest angle is 5, represented by 5x. So I'll take 5 times 15, and that's 75 degrees. Number 2, the ratio of the measures of the sides of a triangle is 9 to 12 to 5. If the perimeter of the triangle is 130 feet, find the measures of the sides. Let's multiply this ratio by x, 9x to 12x to 5x. Now each of these terms represents a side. Let's add them together. 9x plus 12x plus 5x equals, well, all these sides added up together equal the perimeter, 130. So there's our equation. Add this up. This is 21 plus 5, that's 26x equals 130. And if we divide both sides by 26, we get x equals 5. But I'm asked to find the measure of all the sides. So x might equal 5, but the sides are going to be 9 times x, which is 45, 12 times x, 5, which is 60, and 5 times x, which is 5, which is 25. And those will all add up to 130 to make the perimeter. Okay, if two numbers add to 50 and the ratio is 1 to 1, well, that means that they're equal, right? If the ratio is 1 to 1. So this would be 50 divided by 2, which is 25. Or if you wanted to multiply this by x, you would get 1x to 1x, right? 1x to 1x. So just add those up. X plus x equals 50. And then that's 2x equals 50. And notice again, I'm going to divide by 2. So the numbers are 25 to 25. Or 25 and 25. They have a ratio of 1 to 1 because they're equal and they add up to 50. 10 out of 40 students have a cat. So 10 cat out of 40 students. And I'm asked to predict how many students would have a cat out of 2,000 students. So I'm looking for how many have a cat. That's going to be my x. How many have a cat, and it's going to go on top. And 2,000 is going to go on the bottom. How many have a cat matches how many have a cat, and I cross multiply and solve. So that's 20,000, because 10 times 2,000 is 20,000, equals 40x. I divide by 40, I get my calculator, right? Okay, so 20,000 divided by 40 is 500. So x equals 500. Out of 2,000 cats, 2,000 students, 500 would have cats. And that's if 10 out of 40. That's a 25%, by the way. Solve for x. Cross multiply and solve. 35, right? 5 times 7 is 35, equals 6x. Divide both sides by 6, and we get x equals 35 over 6. That cancels, and there's our answer. Maybe that's a fraction. Okay, cross multiply and solve. So 4 times x minus 2 equals 3 times x plus 5. So that's 4x minus 8 equals 3x plus 15. I'm just distributing. Subtract 3x from both sides. I get negative 8 equals, x minus 8, this is 1x, minus 8 equals 15. Add 8 to both sides, and x equals 23. Okay, number 7, cross multiply to solve for x. You get a times x equals b times c. If I want to get x by itself, I divide by a, and that will cancel that. X equals b c over a. Write this out. This is corresponding sides of similar triangles are proportional. You write it out in real words. I'm just doing it quickly. Write this one out. Corresponding angles of similar triangles are congruent. Memorize it. Okay, number 10. We're given this triangle ABC is similar to triangle PQR. Find the scale factor from triangle ABC to PQR. So I'm going to find a pair of corresponding sides. Well, A corresponds with P, and B corresponds with Q, and C corresponds with R. So if I want to find a scale factor, I can see that this side here and this side here correspond. So 4 goes to 9. 4 over 9. We're going from this triangle to this triangle. Now if I want to find x, I'm going to need to set up a proportion. So that was A. For B, I need to find x. So I'm going to use 4 over 9. So 4 is to 9 as 10 is to x. So this side and this side correspond. And now I have my proportion. I can cross multiply and solve. 4x equals 90. Divide by 4. And x equals, if I divide that by 2 and divide that by 2, I get 45 over 2. If you put it in your calculator, you'll get 22.5. I will accept either answer, the fraction or the decimal. Number 11, find the scale factor from this figure to this one. This is a little fuzzy, so notice that these are 2 lines here, and this is 1 line here, or 1 little curve. So this angle is congruent to this one, and this one is to this one. So if I'm going to find the scale factor from this figure to this figure, I'm going to take this side here, and it's going to correspond to this side. So for A, 15 corresponds to 20. I can simplify that. Divide by 5, divide by 5, and we get 3 over 4. There's my scale factor, 15 to 20, going from this in this direction. Now if I'm going to find x, I need to set up a proportion. So I'm going to go ahead and use this scale factor, 3 to 4, as x plus 9 is to 4x plus 3. Going this direction, so I'm staying in that direction. And then you cross multiply and solve. So 3 times 4x plus 3 equals 4 times x plus 9. Distribute. 12x plus 9 equals 4x plus 36. Subtract 4x from both sides. And we get 8x plus 9 equals 36. Subtract 9 from both sides. And we get 8x equals 25. Running out of room here. Divide by 8. Divide by 8. And x equals 25 over 8. Just leave it like a fraction. Okay, number 12. If this triangle here is similar to this triangle here, find x. Okay, so let's be careful here. N corresponds with S. So this angle corresponds with this angle, and M corresponds with R. And then these are, of course, congruent because they're vertical angles. So if I want to find x, I need to set up a proportion. And I can start here on this side. 8 corresponds to 3 as x. I'm starting with the same triangle. First I did this one. 8 corresponds to 3 as x corresponds to 7. So I'm going to cross multiply and solve. 56 equals 3x. Right? Divide by 3. And x equals, well, 56 over 3. And for those of you who love to use that calculator to get a nice decimal, ooh, it's not a very nice decimal. It's 18.6 forever and ever and ever. So this is really the better answer. And I just did that problem completely wrong. I didn't think that looked right. Let's try that again. The corresponding side is not 8 to 3. The corresponding side is 8 to 7. This 8 comes in between this angle and this angle. This side does, I mean. And this side also comes between a 2 tick mark and a 3 mark. So it's 8 to 7, I'm sorry. So 8 to 7, and then x to 3. That's the proportion. This side corresponds to this side, and this side corresponds to this side. So we're going to cross multiply and solve. That's 7x equals 24, and divide by 7, and we get x equals 24 over 7. Okay. Number 13. If this triangle is similar to this triangle, let's look at the angles. K is similar to V, and L is similar to W, and J is, congruent to U. So K is congruent to V, L is congruent to W, and J is congruent to U. So now I can set up a proportion to solve for x. Let's see. 5 and 4 are corresponding because 5 and 4 come between these two congruent angles. So 5 is to 4 as 4x minus 2 corresponds with 2x plus 2. So I went from 5 to 4, so now I'm going to go from 4x minus 2 and go to 2x plus 2. Cross multiply and solve. Okay, that's 16x minus 8. And that I'm just distributing in my head, and this is 10x plus 10. If I subtract 10x, I get 6x, and if I add 8, I get that. So I get x equals 3. And that is correct. Okay, number 14. Set of similar triangles. Here's a triangle inside this triangle, and notice these are corresponding angles and they're congruent, and these are corresponding angles and they're congruent, so these are similar. So my corresponding sides are going to be x and 3, that's one pair, and then the other pair is going to be 4 and 5. So x compared to 3 as 4 compared to 5. This side compared to this side. Whoops, I don't want to make the same mistake again. We're going to go from the big one to the small one. So now we're going to go from the big one to the small one. And that's the correct proportion. Big triangle to small triangle. Big triangle to small triangle. Cross multiply. 4x equals 15. X equals 15 divided by 4. Right, just divide both sides by 4. Okay, number 15. since these two lines are parallel, I know that this angle is congruent to this one, and this angle is congruent to this one. So now when I do my setting up my ratio, it's going to be this side compared to this one, this and this. So 8 is to x. This side corresponds with this side of the triangle, and this side corresponds with this side of the triangle. Cross multiply and solve. 56 equals 5x. Divide by 5, and you get x equals 56 divided by 5, and you can just leave it just like that. Okay, determine if the following triangles are similar. And here is a triangle nestled inside this triangle. So I already know that this angle is an angle that they share, and so that's a congruent angle right there. But also these lines are parallel, so these angles here are corresponding. So there's a pair of angles here that they share, and then here's another pair. So these are similar by AA. So triangle XYZ is going to be similar to triangle RQZ. Number 17. I have two angles here given, so I can find the third angle. 53 plus 60. 114, so 180 minus 114 equals 66. If I find the other angle over here, we have 110, this one's 70. So do we have two pairs of congruent angles? We have one here, 61 and 61, but that's it. So we need two angles, remember, in each triangle. This is no. They are not similar. Okay, number 18. We're given an angle and then sides on each side of that angle. So we're going to try to prove them similar by side, angle, side. So the sides have to be proportional. 4 to 6 has to equal 5 to 10. If I simplify this first one, I get 2/3. And if I simplify this one, I get 1/2. So 5 to 10 is 1/2, but 4 to 6 is 2/3. These are not equal. So these are not similar. And we don't have anything else to do with that. Now here we have three sides of this triangle given, and this side, three sides of this triangle given. So we're going to try to prove that they're similar by side, side, side. So we have to show all the ratios are the same or proportional. So I'm going to take the short side here, that's 15, and compare it to the short side over here, which is 24. Then I'm going to take the medium side here, which is 20, and I'm going to compare that to the medium side over here, which is 32. And then I'm going to take the largest side here, 25, and compare it to the largest side over here, which is 40. Now if these ratios all reduce to the same number, then these two triangles are similar by side, side, side. So I can divide this by 3 and I get 5/8. This here I can divide by 4. That's 5/8. And this can be divided by 5. Oh, look at that, 5/8. All three ratios are the same, so this is similar by side, side, side. And triangle GHI is similar to triangle QRS. Number 20, find the variables in each and leave answers as fractions. So number 20. Notice that this is one big triangle cut into another, another triangle, and this side is parallel to this side. So we can set these pieces as ratios as a proportion. So 3 goes to 5 as 4 goes to x. We can set this chunk to this chunk equals this chunk is to this chunk. Okay, so by the triangle proportionality theorem, I can say this piece is to this piece as this piece is to this piece. Now, I could also go across. I could go 3 is to 4 as 5 is to x. And you'll notice that the cross products are going to be exactly the same. 3x equals 20. And here we get 3x equals 20 also. Divide by 3, we get x equals 20 over 3. Now, using similar triangles as well, I'll show you what I mean. I could take 3 from this triangle and compare it to the whole side, which is 8. And I could take this piece, 4, and compare it to the whole thing, which is 4 plus x. And then you could solve this proportion as well by corresponding sides, 3 to 8 as 4 is to 4 plus x. But this triangle proportionality theorem makes it a little easier, piece to piece, piece to piece. Now if you solve this, you're going to get this answer. Okay, 21 is the same setup. We have a big triangle and it's cut into 2 triangles by a piece that is parallel to this side. So we can use the triangle proportionality theorem. This piece, 4, is to 3, as this piece, x plus 2, is to 5. Now notice I'm using this piece and this piece compared to this piece and this piece. I'm not using anything with this. Cross multiply and solve. So 5 times 4 is 20. And that equals 3 times x plus 2. So 20 equals 3x plus 6. Subtract 4. 14 equals 3x. Divide by 3. And we get 14 over 3. So x equals 14 over 3. Remember I told you there's going to be a lot of fractions. Okay, number 22. Again, we have a triangle that has been cut with this piece right here that is parallel to this side. However, if we want to find x, we cannot use the triangle proportionality theorem. The triangle proportionality theorem only applies to the side pieces here that have been cut. These pieces are whole pieces. So we need to use similar triangles. So this triangle compared to this big triangle. So if I want to find x, my proportion could be 3, this side, is to the whole side of 10. Right? This big triangle is 10, the small one is 3. So 3 to 10 equals, the bottom piece is 5, and this big bottom piece is x. And there's one proportion that would work. If we cross multiply, we get 3x equals 50. Divide by 3, and we get x equals 50 over 3. Now, I could have also set it up like this, and people like to do this. 3 is to 5. So 3 is to 5 as, and then they take this whole piece right here, 10 is to x. And you'll get, look, almost the identical proportion. The cross products will be the same. And you'll get the same answer. Okay, number 23. Now, in this figure, we're going to use both methods, the triangle proportionality theorem and similar triangles. So if I want to find x, how would I like to do this? I'm going to say that my proportion is going to be 7. This piece is to this piece, is to 2, as, well, what's this piece going to be? If I'm putting chunk to chunk to chunk to chunk, then 7 to 2 as, well, this whole thing is x, then this piece right here is going to be x minus 3. So x minus 3 to 3. 7 is to 2 as x minus 3 is to 3. And that's using the pieces. So I'm going to cross multiply, and I get 21 equals 2x minus 6. I'm just distributing. 2 times x minus 6. Add 6, that's 27 equals 2x. Divide by 2, we get x equals 27 over 2. Now, to solve for y, I will have to use similar triangles. I'm going to use this side, this pair of sides. So to solve for y, I'm going to take 7 and compare it to the whole side. So the side of this smaller triangle, 7, corresponds to this whole side, which is 9. So this piece of the triangle to the whole, this whole piece of this triangle equals y to 14. 7 is to 9, pieces to the whole, or let me say that again. Small to the large, small to the large. Cross multiply and solve, and we get 7 times 14 is 98 equals 9y. Divide by 9, and y equals 98 divided by 9. I don't know if there are any common factors in there. No, I don't think so.
It's not today.
Okay, let's look at this picture right here. And we have a bunch of parallel lines cut by 2 transversals. And we have some pieces here so we can make some ratios and proportions to solve for some of these numbers. Now, if I want to solve for this whole piece of x, well, this is pretty simple, actually. I can take this whole piece right here, which is 7. Okay? Now I've added these two together. So 7 goes to 2 as x goes to 3. Now you could go across, you could say 7 is to x as 2 is to 3, and you'll get the same cross product. 21 equals 2x, so x equals 21 over 2. And you're done. Okay, 25. Oh, this is an oldie but a goodie. These are vertical angles, so they are congruent to each other. So 4x plus 20 equals 5x minus 20. And let's subtract 4x from both sides. And we get 20 equals x minus 20. Add 20 to both sides. And x is going to be equal to 40. 26. Parallelograms. Opposite angles are congruent, but consecutive angles are supplementary. And if it helps you remember, these are parallel lines, so if I extend these sides out, these are consecutive interior angles, and consecutive interior angles are supplementary. So 2x plus 10 plus 3x plus 20 equals 180. This is 5x, and this is 30. That equals 180. Subtract 30 from both sides, and we get 5x equals 150. Divide by 5. X equals 30. 27, this is a mid-segment. How do I know that? Because this segment inside of this trapezoid is dividing this side into congruent pieces and this side into congruent pieces. So this is a mid-segment, which means that to find x, I add the two bases, so 13 plus 25, and divide by 2. That is 38 divided by 2. X equals 19. (28) is the angle bisector theorem, which says in a triangle, if you have an angle bisector, it divides the opposite side into two pieces that are proportional to the sides that make that bisected angle. So what does that mean? I can take 4 and compare it with 6, and that will equal 10 over x. I can also go across. 6 is to x as 4 is to 10. We go 6 is to x as 4 is to 10. Remember, this is that strange theorem that is just a little bit different than all these other similar triangle and triangle proportionality theorems that we've been working with are. Cross multiply, 4x equals 60, divide by 4, x equals 15. Fill in the blanks. In this figure, this special segment right here, AB, that is called an altitude. We will also sometimes call it a height. And QT in number 28, this piece right here, well, that's the angle bisector. Okay, find the sum of the interior angles of a 17 gon. Remember, this is interior angles, and we're asked to find the sum. So we're going to use this interior angle sum formula. 17 sides, so S sub I equals 17 minus 2 times 180. That's 15 times 180. And on my calculator, I get 2,700. And that's the sum of all the angles in a 17 gon. Number 32. Find the sum of the exterior angles of a 17 gon, same number of sides for this polygon. But now I want the sum of the exteriors. I want the sum, but this time of the exterior, and that's always going to be 360. If the sum of the interior angles of a polygon is 180,000 degrees, find the number of sides. So I'm talking about the interior angles here. So S sub I equals n minus 2 times 180. And I'm told that the sum is 180,000. So I put that in for the sum. And now I'm going to solve for n. And probably the quickest way is to divide this by 180 and divide this by 180. So that's 1, 0, 0. Maybe one more 0. 2, 0, 2, 2. By 18, 2. And more 0. 1,000 equals n minus 2. This is the part that students forget. This n minus 2 is still there. So before I'm done, I need to add 2 to both sides. So the answer is 1,002. Okay, number 34. Each interior angle of a regular polygon is 174. How many sides does it have? So each interior angle. So I'm not going to do this the long way. I'm going to do this the short way. I'm going to do my unfinished gon. And the interior angle is 174. So that means the exterior angle is 6. Right? These have to be supplementary. So if I take 360 and divide it by 6 degrees, I get 60. This has 60 sides. Number 35. Oh, I have 2 number 35s. Number 35. The ratio of sides of a parallelogram is 1 to 1 to 1 to 1. What shape must it be? Okay, so the ratio of sides of a parallelogram is 1 to 1 to 1 to 1. Here's my parallelogram, and all the sides are the same. This is most definitely a rhombus. Are the diagonals congruent in a rhombus? No. Notice it's squished a little bit, so this is a little bit longer than this one. Do the diagonals bisect the angles? No. Oh, sorry. Yes, in a rhombus, the diagonals bisect the angles. Now, some of you might be inclined to call this a square. Well, a square is a kind of a rhombus. So this is most definitely a rhombus. And the diagonals are not congruent unless it happened to also be a square. But we can't guarantee that. So if this happened to be a square, then yes, the diagonals will be congruent. But we're going to say no because we don't know that. And do the diagonals bisect the angles? Yes. Okay, the perimeter. Okay, I'm going to draw a picture. triangle VWU, the perimeter of triangle VWU is 18. So this perimeter is 18. Now, VWU is similar to triangle X, Y, Z. Notice V corresponds with X, W corresponds with Y, and Z corresponds with U. So I want to make sure that my triangles are set up so that I can see this and this side, this angle and this angle, this angle and this angle, and this angle and this angle are all corresponding. Okay, VW is 8, and WU is 4, and YZ is 10. Okay, I'm just labeling my triangles. And I'm asked to find the perimeter of this shape. Well, we already know the perimeter of this shape is 18. So remember, the perimeters are going to be proportional to the corresponding sides. So if I can find a pair of corresponding sides, in this case, 4 corresponds with 10. So I'm going to go this direction. 4 compared to 10. This is going to be the bigger triangle. So 4 corresponds with 10. Notice it's in between these two congruent angles. So 4 is this side and corresponds with this side. And then this perimeter is 18, and we don't know what this perimeter is. We're trying to find it. Now all these sides are going to be proportional, and so is the perimeter, or the perimeters. So 4 over 10, I'm going to cross multiply. 4p equals 180. Divide by 4. P equals 180 divided by 4 is 45. Okay, and that was the study guide. I hope this helps. I'll see you in class.